All right, so this is a super quick video. Basically, this is 6E. This is our second 6E. And this is a confidence interval for the difference in proportions. So here's just a little tiny bit of review. So when we are comparing two proportions, that's what this is. So when we compare two proportions, we're going to base this on random sampling or randomized experiment. And this is what we want to see. We want to determine whether the two treatments cause an observed difference. And so from that, we want to draw conclusions about the population. So what we had, sorry, I'm trying to make this a little clear. I'm not sure what's going on today. So we have a sampling distribution, and here is our sampling distribution. And what we had was p hat 1 minus p hat 2. Now this is a sampling distribution. This is not a confidence interval. All right, so when we're reviewing this, we had P1, p hat 1 was our first sample, and then p hat 2 was our second sample, okay? And so our conditions, of course, we've seen this so much, we know that it's approximately normal, and we get this if we satisfy our large counts. So we have our large counts condition, and that's going to be our number of our sample size of our first times our proportion of our first, and that has to be greater than or equal to 10, and then of course the opposite, so 1 minus P1, and then the same thing for our second population. We need whatever this second proportion group is, we need this population group to also be greater than or equal to 10. Okay, so our center. Now, our center is going to come straight from our formula sheet. So here for two populations, so here's our center. That hasn't changed. So our center of p hat 1 minus p hat 2 is going to be the proportion of 1 minus the proportion of 2. And again, we see this under sampling distributions. Remember, we're talking about sampling distributions right now. Okay, and we know that this is true as long as we have an SRS or random assignment. And then our spread is our standard deviation, and we see this right here too. So what we see is p hat of the first one, p hat of the second one. Now, this is where, actually it's right here, this standard deviation. So let me just write that down so we have this in one place. So the standard deviation of my first sample minus my second sample is P1 and 1 minus P1 over N1 plus P2, 1 minus P2 over N2. And this, again, this is for a sampling distribution, and we know that this is true as long as we meet the 10% condition. And again, that was the first sample has to be less than or equal to 10% of our overall population, and then so does the second one. And if you remember, this is only with sampling. This is not an experiment. Okay, so now let's compare what we just did here with when we have a confidence interval. Now, confidence interval, of course, this is the unit that we're in right now, but you need to be able to distinguish between the two of them when you get on an AP test. And so this is a confidence interval for a difference between two proportions. So again, what we see from our formula sheet is we have this confidence interval, and it's our statistic plus or minus the critical value times the standard error of the statistic. Well, this is not going to change. So we know our statistic from just a single sample is going to be p hat, and we say plus or minus our critical value, and that was our z star value, and then we had our standard deviation, and our standard deviation was p hat 1 minus p hat over n. So this was for a one sample z interval. Okay, so when the conditions are met, now we're going to use this as a difference. This is the difference between the two. So we're going to pull the stuff that we did with our sampling distribution down here for our confidence interval. So again, we know this, but p hat is the statistic, and this comes from our sample, and p is our parameter, and this comes from our population. Okay, so it's important we keep this keep this separated because we're going straight from confidence intervals back to z-test. So we need to make sure we've got this, the understanding here. So here's what we have. So now we have a difference between these two. We want to see if there's a difference. So now my statistic is p hat 1 minus p hat 2 plus or minus z star, which doesn't change. And now I'm going to use my standard deviation of p hat 1, 1 minus p hat 1 over n1, and then our second sample proportion. Okay, and again it says right here, z is the critical value for the standard normal curve, with percent %c being the area in between. So we've done this before, but what this is going to be is we have a z star here, and we have a z star here, and these z stars are going to be symmetric based on whatever our confidence interval was. And we get that from our normal inverse norm. All right? Okay, let's go straight to an example problem. So we have this problem. It says a recent survey wanted to compare the proportion of teenagers and adults who use social media. The first poll asked a random sample of 300 teenagers if they use social networking site. A second random sample asked 400 adults if they used a networking site. In these two samples, 92% of teenagers used social networking, 75% of adults did. Construct and interpret. That means we need all four parts of our confidence interval to see if there's a difference between the proportions. All right, so first thing I have here is my communicate. So with my communicate, I am going to go ahead and say that P1 is the proportion of teens who use social media. P2 is going to be my proportion of adults. Who use social media. All right, let's see, what else do I know? I know that, let's see, my x1 value here is, hold on, this is my n1 value. That's going to be 300 teenagers, and my n2 value here is going to be 400 adults. It says 92% of teenagers. So if I have 92% of teenagers, that is going to be my p hat. So this is 0.92. And 75% of adults, that's going to be my 0.75. And we want to construct a 95% confidence interval. So with that 95%, I'm just going to go in right now and get my z star value. So inverse norm, and I have 0.95 as my area. So 1.96. So I can go in here right away and just say my z star value is 1.96. And I don't even need to show any calculations on that. All right, so now let me go over here and do my conditions. So random sample. It says the first poll asked a random sample, so N1 is an SRS, so that's true. And then a second random sample, so N2 is also an SRS, so that's also true. All right, so now I'm going to, check my independence. So my independence, I have 300, which is less than or equal to 10% of all teens. And I have 400, which is less than 10% of all adults. So we're good here. Now I'm going to check for my normal curve. And what I have here is that 300 times 0.92. So this is my N1 and this is my P1. And I know that's going to be bigger, but I'm just going to find the value. 276. So 276 is greater than or equal to 10, so we're good here. And then I have 400 times 0.75. So I have 300 is greater than or equal to 10, so I'm good there. So I've checked all my conditions. And again, make it super easy for your grader to know what you've done. Just label it. Just label it. Makes it easy. All right, so now I'm going to go to my calc section. And so now we no longer have a 1 prop z interval. Now we have a 2 prop z interval. Now I'm going to write this whole thing out. 2 prop z interval is okay, but what this really stands for is 2 sample proportions and I want to find a z interval for the population proportion. All right, hold on, y'all. I'm at school and the lights just went out, so hold on. Let me get the lights back on. Okay, so I do my calculation. I'm going to go ahead and write it out this time. So I have p hat 1 minus p hat 2. And what it says up here is we're just looking to see if there's a difference between all teens and adults. So that's why I put my teens first. And then this is going to be plus or minus my z star. And then I'm just going to put standard error right here, and I'm not going to write that whole thing out just to save time today. So when I put the numbers in, I have 0.92 minus 0.75 plus or minus my z star of 1.96, and then when I plug this in, I get 0.92, and then the difference is 0.08. My sample size was 300, and then I do the adults, so I have 0.75, 0.25, and 400. Now, you can plug all that in, or you can just go to your calculator. I'm going to go stat, test, 2 proportion, oh, that's test, don't do that. 2 prop z interval, there we go, number B, letter B, 2 prop z interval. All right, so I don't have this, dang it. So I could go back and calculate it. So if I know that my total amount is 92% and I know the number of students I have, I can calculate this. I guess I'm going to have to do this the old way, which I didn't want to do. So 0.92 minus 0.75 is 0.17 plus or minus 1.96. Actually, I'm going to plug all that in my calculator. 1.96 times the square root of 0.92 times 0.08 over 300, and I'm going to add that to 0.75 times 0.25 over 400. Okay, so plus or minus 0.0523. So what does my interval look like? My interval is 0.17 minus this guy. So this is 0.1176, and then 0.17 plus this guy, 0.2223. Okay, so now let me go over here and do my conclude. Okay, same thing. We are 95% confident. Now, I'm going to go back up here, and I'm going to pull this. I'm just going to pull it right from this description. So we are 95% confident that the difference between the proportion of all U.S. teens and adults who use social networking sites is between 0.1176, 0.2223. Okay, so I'm not going to write all of this out because we've done these conclusions. Make sure you understand it's the same thing. Make sure you include that it's a difference. So if you just go up and capture from that, that should work. So it's the difference between. Okay, so I wasn't thinking on this, but I can show you how to do this. So 2 prop z interval, when we went to the calculator, we see how this works. So I need x1. I don't have x1. I just have my sample proportion. But this is super easy to find. So we know that p hat is going to be x1 over n1. Okay? Well, if I know this is 0.92, and I know that I have 300, my sample size was 300, then my x value is going to be 276. So what does that say? It says 276 out of 300 teenagers use social media. And then I could do the same thing here for p hat 2. I don't know, again, I don't know my sample size, but I know we say 75%, and our sample here was 400 for the adults. So 0.75 times 400 is 300. I knew that. Okay, so now let's try this, and we need to see that we get the same interval. So I go to stat, test, I'm going to go to 2 prop z interval, 2 samples, z interval for proportions, okay? And so the values that I'm going to use here are 276 out of 300, and then 300 out of 400, and my confidence interval is 95%. That's true. Okay, so here it is, 0.1176 to 0.222, okay, which is what we ended up with here. So there's absolutely nothing different with this except for the fact that we've got 2 proportions, so we use 2 prop, and we're finding a difference, so we're subtracting.